Hello everyone, this is Vardman and welcome back. So we will be going to solve few examples on recursive tree method. So let's look at our first example. So here we have the function tn, which is equal to tn by 5 plus t4n by 5 plus n. So this function have two recursive call, which is tn by 5 and t4n by 5, and at each function call there is n unit of time consumed. Let's create the recursive tree for this function. So we have actual value of n as n, and there will be two function call. One is for n by 5, other is for 4 by 5 n, and this will also have two function call. First one will be n by 5 square, second will be 4 by 5 square n, and this will also have same. This side will be 4 by 5 square n, and this side will have 4 by 5 whole square n. So let's say this will run up to k times, and after k times it hit the termination condition, and it will become n by 5k this side, and this side it will become 4 by 5 kn. So this can be written as n by 5 by 4 k. And if we solve this, so after k time this is terminated, so n by 5 will, and k by 5 will become equal to 1, and this will got terminate. And if we solve the value for k, so we will got k equal to log base 5 n. So this will be the value of k this side, and here if we solve this, so this is a similar function, so it will have the value of k equal to log 5 by 4 base n. This side the value will be log 5 by 4 n. So you can see this function is smaller and this is larger, so the value of k is larger for k equal to log 5 by 4 n. So we can say this length, right, this will be equal to log base 5 n, and this side will be equal to log base 5 by 4 n. So you can see the tree will form like, the shape of the tree will be like this. This will be n, and the length here will be log base 5 n, and the length here will be log base 5 by 4 n. Let's find the time complexity is overall recurrence relation. So for the first level it will consume n unit of time, so we can write n. So you can see when the input was n, so it is consuming n amount of extra time at each function call, and when the input will become n by 5, then it will consume n by 5 for that function call, and for second function call it will consume 4 by 5 n, and if we sum up this will become equal to n. For third level we can see we have 4 function call, and for first function call it will be n by 5 square. For second we will have 4 by 5 square, and third will also be same 4 n by 5 square, and for fourth function call it will be 4 by 5 whole square n. So whatever the input is, that will be the extra time consumed. So for n by 5 square it is the input, so it will consume n by 5 square time, so this will be equal to n. And for the k time it will also consume n unit of time, and if we sum of all these values, so we have n plus, for the first level, for second level we have n, for third level we have n, and for kth level we have n. So it will run a total k times. We will perform addition k times, and the value of k here is log base 5 by 4 n. Here you can see the larger depth is log 5 by 4 n. So it will run log 5 by 4 n times, and if we sum of these, so we will get value. So for each level there is n, and for each level there is n, and how many levels are there? There are log base 5 by 4 n levels. So we can write it as big of n log 5 by 4 n, and this can be written as big of n log n. Constant can be ignored. Let's see other example. So we have our recursive relation here. So Tn equal to Tn by 2 plus Tn by 3 plus Tn by 4 plus C. So C is the extra time consumed at each function call. And if we draw the tree for this, so we have Tn, it is calling three functions, Tn by 2, Tn by 3 and Tn by 4. So these will again call three function each, and it will keep on until k times. All three will go up to k times, and at the end of k times, so this will become n by 2k, it will become n by 3k, and this will become n by 4k. And if we find the value of k here, so if we write this equal to 0, so we will get k equal to log base 2n, here will be log base 3n, it will be log base 4n. And if we find time consumed at each level, so for first level it will be only C, for second level there are three function calls, so it will be 3C, for third level it will be 9 function calls, so it will be 9C, and if we simplify it we can write it as 3 raised to the power 0C, it will be 3 raised to the power 1C, it will be 3 raised to the power 2C, and after k time it will become 3 raised to the power kc. And if we sum of these value, so it will be equal to c plus 3c plus 3 square c plus 3kc. So we will take the value of k which is the larger, so larger value of k is log base 2n, because in log, smaller the value of base, the larger the value. So the value of k we will take as log base 2n, and if we sum of these, so we can write it one more time, plus 3c plus 3 square c, this will be 3 log base 2 and c. We will take c common, we'll have 1 plus 3 plus 3 square plus 3 log base 2 n. So this is an increasing GP series, and in increasing GP series the last term is the answer, so we can write it as c into 3 log base 2n, and this can be written as big of 3 log base 2n, and this can be swapped, this will become log base 2 3.